Chapter 7, Number 35. To compress spring 1 by 0.2 meters takes 150 joules of work. Stretching spring 2 by 0.3 meters requires 210 joules of work. Which spring is stiffer? This is really comes down to being just do some grind out some calculations. There's no easy way to see which one will come out first. So case 1, the work done in spring 1 is going to be 1/2 times the spring constant of 1 times the distance squared. And although they say compress in one case and stretch in the other, it doesn't really matter because that square, the minus sign is going to cancel out. So we can figure out that K1 is the work done over 1/2 s squared, or 150 joules divided by 1/2 0.20 meters quantity squared, and we get 7,500 joules. And then the same kind of thing happens for work 2, where we have 1/2 K2 S2 squared, and so K2 is work 2 over 1/2 S2 squared, which is 210 joules over 1/2 times 0.3 meters quantity squared. And we get 4666 newtons per meter. And let me fix this up here. Should have been newtons per meter. That's what happens when you don't track your units very carefully. But I have joules over meter squared, which is the same as a newton meter over meter squared, which is a newton per meter. I haven't tracked the sig figs because they're really not going to be relevant. Clearly, spring 1 has a larger spring constant, and we call that a stiffer spring, which is just a term of art.